Welcome back to another exciting chemistry lesson. In this lesson, we are going to learn how to classify our chemical reaction as synthesis, decomposition, combustion, single replacement, double replacement, or acid-base reaction. In a synthesis chemical reaction, two or more reactants combine to form a single product. The word synthesize means to make, okay? So what are you making? You're making from two or more reactant you combine together. In this case, you have chlorine gas and hydrogen gas combined together to make HCl. Okay, and as you can notice, chemical reaction occur when we have bonds are broken, atoms are rearranged, and new bonds are formed. As you can see here, the hydrogen and chlorine form a new bond to make this new product, hydrochloric acid, or HCl. Now, in a decomposition, think of the word decompose. When you decompose, what's happening? If a substance is decomposed, it's break apart, right? Like matter decompose, it break down into smaller parts. So in a decomposition, it's the opposite of synthesis. You have a single product decomposed into a smaller reactant. So you have a single reactant broken down into two or more products. In this case, we have two or more products. Well, we have water. It can be broken down into, in this case, it is broken down into hydrogen and oxygen. And again, the chemical bonds are broken and the atoms are rearranged to form new substance. Then we have combustion. Every time you hear the word combustion, you think of fire, right? If something is combustible, it is flammable. So think of it that way. Combustion is basically a substance, an element or compound react with oxygen. In most cases, we have a very specific type of very combustible type of chemical. It's called hydrocarbon. And hydrocarbon, think of hydrogen and carbon, okay? So that's the basic structure of hydrocarbon. It has a hydrogen, well, it has hydrogen and carbon in it. And of course, it has other substance or other elements as well. But hydrocarbons are very combustible. And in a combustion reaction, you produce heat, which can be observed in form of light, okay? And that can be observed in terms of increase in temperature changes. So increase temperature, you will see that right away, because you are producing heat and other products. And in a hydrocarbon, you will observe the product of carbon dioxide and water. Then now we get to single replacement. Think of the word replace. Now, another word of replace is displacement, okay? But I think the best term is replacement because one element in a compound is replaced by a more reactive element. Now, another term of reactive is more active because basically when we look at single replacement, you have metals, hydrogen, and non-metals. And the way it works is that you have a list, and if you notice here you have increasing activity. That means the more active it is, it's gonna replace the one that's less active to illustrate. Okay, so to illustrate this, we have potassium right here, which is right here, all the way to the top, which is the most active for the metals and hydrogen, right? And this compound you have hydrogen. So hydrogen's right here. So this is more active. Okay? Based on the chart. So therefore, it's going to go in and replace the hydrogen. Now, when we replace the hydrogen, where is this hydrogen going to go? Of course, it's going to be floating around and it's going to combine with other hydrogen. And that's the next part of the problem is that what is going to happen with those elements that are going to be displaced from the compound or get kicked out from the compound? Well, they become neutral elements. And in most cases, they become diatomic elements. Now, there's one very important fact that you have to remember. Before we do that, we need to cross out carbon. Carbon is not there. But basically, if you kick out a metals like aluminum or calcium, it will become a solid neutral element metals, right? But what about the gases? The gases don't really exist by itself. It has to be bonded with something else to be stable. So we have a specific rules that for certain element, especially for the non-metals, they will form a diatomic molecule. Di means two, so basically it form a diatomic molecules. And if you look at this, bromine, iodine, chlorine, and fluorine, those are the halogen in group 7A. Okay, that makes sense because they are very reactive. And then we have nitrogen and oxygen and hydrogen. Those are very reactive gas as well. So these are the elements that will form diatomic molecule when it get displaced from the compound. So keep that in mind. Now, what happens when you have two substances when you mix them together, but the other one is non-reactive? But in this case, copper is right here, right? Copper is right here, and this is hydrogen. Because copper is less active than hydrogen, it would not go in and kick out the hydrogen. So therefore, no reaction. Copper just stay there. Let's go look at another example. Here we have chlorine. Chlorine is right here, and we have bromine right here, right? So notice how this is negative and this negative. Positive replace a positive. Positive replace positive. Negative replace a negative. So chlorine's right here, bromine's right here. So chlorine is high, so therefore it's going to come in and kick that bromine out. And again, you see the diatomic molecules right there, see? And let's go down here, we look at another example. We have bromine right here, then we have chlorine. In this case, bromine is lower, so it's not going to come in and kick the chlorine out. So again, no reaction because bromine again is less active than chlorine. So that's the logic behind. So that's the logic of using the activity series or the activity chart to determine if the chemical reaction is going to occur or not. Then in a double replacement reaction, what you have here is a cations and an anions, which is positive and negative. In two compounds, they are exchanged. And this is a little bit tricky, okay? So I'm going to write this out for you, okay? First of all, what we have here is, let's assume A is plus and B is minus, okay? And of course, in a compound, you would not write A with a plus and B with a minus. You just write AB. React with C plus and D minus right there. Of course, you have the positive first followed by the negative. And if they are going to exchange, okay, notice how we have this right here. So you're going to exchange that, okay? See how that works? So what we have here is we're going to have A plus, and now this is going to exchange, okay? Exchange one of them. So what we need to do, either one, okay, it doesn't really matter. In this case, it could be any one of them, okay? So you can either use this one or that one. So in this case, we have A now going to be with D minus, and then C plus is going to be with B minus. Now to illustrate this with a real example, what you have here is, let's look at this one. We have lead, nitrate, NO3, 2 minus. There you go. And then this is going to combine with potassium iodide. Again, this is a positive charge. This is a minus charge right there. So we are going to exchange the negative ions. How about that? You can do with the positive one if you want to. But in this case, we have lead. And remember, lead has a 2 positive, so we need 2 iodine to mix together, right? To balance out the charges. And then over here, we have potassium. Notice how here we have 2 nitrate, but in the end, when potassium, it only has +1, so we have KNO3. See how that works? So that's a very tricky part. You had to balance out the charges, doing this together at the same time. So that would make it more challenging, okay? So notice how the iodine and nitrate are now exchanged to form complete 2 brand new products. Now you have to be very careful with double replacement. Sometimes when you mix substance together or solution together, doesn't mean there is going to be reaction. The only time there is going to be reaction when there is precipitate form. So you have to apply the solubility rules, and we are going to look at that next. Okay, solubility rules. It has to be a precipitate that's formed in a chemical reaction through this mixture. And precipitate again is a solid. And how do you know? It looks cloudy. Or in other cases where you have water form or a weak acid or base form. Okay? And then in the third situation where you have gases form, and gases when it form, it's going to escape. So those are the 3 situations where you have a double replacement reaction occur. If it doesn't have one of those, you can mix substance together. Doesn't mean there's going to be a reaction. And the last one we have is going to be an acid and base reaction. Now, acid-base reaction, basically, an acid reacts with a base. And a common acid is HCl, and a common base is NOH, okay? And of course, we are going to cover this acid and base reaction more in detail has a lot of properties that we have to look for. Okay, so in this case, it is look like a double replacement. You think about it. See how this is negative, it's positive, positive, and this whole thing is negative. We just switch it out, okay? Switch it between, and we just exchange the two ions. So in this case, we have HOH, which we can write as water. See that? And then right here, over here, we have what? We have NaCl. Isn't that nice? So that is a common acid-base reaction. And so in a way, acid and base reaction is a specific type of double replacement, but it's more than that, okay? We are going to look at acid and base reaction more in detail. Now let's do some practice problem. So in this case, for synthesis, decomposition, and combustion, you just type in normally, but for single replacement and double replacement, you have to just type in the word single and double for double replacement. In this case, H2O2, and then we produce water and oxygen. What is that? Well, that is decomposition. Okay, and here we have CH4, which is a hydrocarbon right there, react with oxygen and produce heat. Look at that. Of course, right away we know that is a combustion. And here we have this right here, react with oxygen. Right away, whenever you see react with oxygen, think of combustion. And we can see that's heat. We see carbon dioxide is being produced. So this is also combustion. See how easy it is to identify chemical reaction? And here we have two reactions forming a single product. So that is synthesis. Isn't that nice? Easy, isn't it? And here you have an acid-base reaction. This is an acid right here. And this is a base. So again, acid and base is a specific type of double replacement in most cases. So this is an acid-base reaction, okay? And as always, if you have any question about this video or the practice, please take a picture of your work and put in the form, and we will help you from there. And we see you next time on another exciting chemistry lesson.